A power cut doesn't need to last all day to ruin a full day of work. Sometimes it only takes 1 second. Your desktop shuts down, the meeting disappears, the router goes dark, and the document you were absolutely going to save in another minute becomes a lesson in why autosave is such a comforting word. So, how much backup power does your home office actually need? The answer isn't simply the largest battery you can afford. You need to solve two different problems. First, can your backup system stop important equipment from shutting down when the electricity fails? Second, can it keep that equipment running for as long as you need to work? Those sound like the same problem, but they aren't. A UPS may protect your computer from the first instant of a blackout, but provide limited runtime. A portable power station may contain much more energy, but its switching behavior may not protect every desktop computer from interruption. By the end of this video, you'll know how to separate those two jobs and choose a system around your actual office, not the impressive numbers printed on a product page. Start with 3 questions. What equipment must remain powered? How long must it continue running? And which devices cannot tolerate even a brief interruption? Imagine Shelley working from home when the power fails during an important video meeting. She uses a laptop, so the computer continues running on its internal battery, but her router shuts off, the call freezes, and everyone gets to study the least flattering frame of her face. Her main problem wasn't the laptop, it was the internet connection. Now place Shelley at a desktop computer instead. The power fails and the entire workstation shuts down immediately. In this situation, she has 2 problems: protecting the computer from the instant interruption and finding enough stored energy to continue working. That difference changes what she should buy. Before choosing any backup system, build the smallest office you genuinely need during an outage. Your essential list might include your work computer, 1 monitor, the router or modem, necessary storage equipment, and a phone charger. Your optional list might include the second monitor, speakers, decorative lighting, and the printer. Your printer has survived several weeks without being useful. It can probably survive the blackout too. Reducing the load can save more money than buying a larger battery. A laptop office is usually the easiest situation because the computer already contains a battery. Your backup system may only need to support the router, phone, and laptop charger for longer outages. A desktop office needs more planning. It may require immediate interruption protection, higher sustained output, and considerably more stored energy. A professional editing, engineering, or gaming workstation can demand even more power, especially when the processor and graphics card are working hard. That brings us to the number most people get wrong. If your desktop contains a 750 watt power supply, that doesn't mean the computer constantly consumes 750 watts. The rating describes what the power supply is designed to provide. Your actual consumption changes with the work being performed. Reading email, joining a meeting, and exporting a large video can produce very different power demands. So instead of guessing from the computer's power supply label, measure the complete office while you perform the work that matters. That measurement is where your real backup power decision begins. A plug-in power meter can show how much electricity your office is using from the wall. Connect the office equipment you want to measure, then observe it during normal work and during a demanding task. If you edit videos, measure while exporting. If you use design or engineering software, measure during a heavy project. If your work consists mostly of documents and online meetings, reproduce that ordinary day. You're looking for the realistic working load, not only the lowest idle reading. You also need to know the highest load that may occur while everything is operating. Your backup system's continuous output must comfortably support that demand. Once you have the working load, you can estimate the stored energy you need. Suppose your desktop, 1 monitor, and networking equipment use a combined 220 watts while you work. You want 4 additional working hours. 220 watts multiplied by 4 hours gives you 880 watt hours, but a power station labeled 880 watt hours shouldn't automatically be treated as an exact 4-hour solution. The inverter consumes some energy while converting battery power into household AC power. The system may also reserve part of the battery, and your computer's load can change, so you add a practical allowance for conversion losses, changing demand, and some remaining reserve. Instead of shopping for the mathematical minimum, you might begin comparing systems around the next suitable capacity range above it. The calculation isn't the final answer, it gives you a realistic shopping area. Now watch what happens when you change only one part of the office. Turn off a 40-watt secondary monitor for those 4 hours, and you remove approximately 160 watt-hours from the basic requirement. Reduce the workload on a powerful desktop, and its consumption may fall further. Use a laptop instead of the desktop during a long outage, and the required battery could become much smaller. That is why the smartest backup system sometimes begins with an outage working plan, not another battery. Decide what work can continue normally, what can move to the laptop, and what can wait until utility power returns. But stored energy still doesn't solve the first second of the blackout. A traditional uninterruptible power supply, or UPS, is designed to protect connected equipment when utility power fails or moves outside acceptable conditions. A standby UPS normally switches to its battery after detecting the problem. That creates a brief transfer delay. A line interactive UPS can also correct certain high or low voltage conditions without immediately consuming its battery. When utility power fails, it switches to battery operation. An online double conversion, UPS continuously supplies the protected load through its conversion system. That design can provide zero transfer time, but it normally costs more and may be unnecessary for a basic home office. Many ordinary computers can tolerate the short transfer time of a suitable standby or line interactive UPS, but many isn't the same as every. Compatibility depends on the UPS, its output waveform, the computer's power supply, and the connected load. Some cheaper systems produce a simulated sine wave while operating on battery. Sensitive or high-performance equipment may require a pure sine wave output. This is why choosing a UPS by its battery size alone can still leave you with the wrong product. The UPS must support the load, switch appropriately, and produce an output your equipment can accept. Then you decide how much runtime you expect from it. A small UPS may provide enough time to save your work and shut down safely. That can be exactly what you need if outages are brief or another power source starts soon afterward. But if you expect to keep working for several hours, a typical small UPS may not contain enough battery capacity. That is where a portable power station becomes attractive. It can provide much more stored energy, power several office devices, and, depending on the model, recharge from the grid, a vehicle, or compatible solar panels. Some power stations also advertise a UPS or emergency power mode. This can allow connected equipment to receive utility power normally and switch to the internal battery when the grid fails. But don't treat the word UPS on every product page as if it describes identical performance. Switching times vary by model. Some manufacturers advertise switching below 20 milliseconds. Certain models may switch faster. Others may describe their feature as an emergency power supply rather than a traditional UPS. Your computer's power supply may tolerate that switching gap, or it may shut down. You also need to check the maximum load supported while the power station is operating in that mode. Confirm whether its AC outlets remain active continuously, whether power-saving settings can shut the output down, and whether the manufacturer permits the kind of continuous operation you're planning. If protecting an active desktop session matters, verify the exact model's documentation rather than assuming that a large battery guarantees uninterrupted operation. You can also use a dedicated UPS for immediate protection and a larger energy source for extended runtime, but don't blindly connect one device into another and assume the combination is safe and compatible. Some UPS units can reject the output from another inverter. Charging and bypass behavior can differ. Grounding arrangements, load limits, and manufacturer restrictions still apply. Use a combination that both manufacturers permit and test it under controlled conditions before trusting it during an important workday. For complex or permanently connected systems, involve a qualified professional. Now let's turn this into 4 practical office levels. Level 1 is a laptop, router, and phone. Because the laptop contains its own battery, your first priority may be keeping the internet equipment running. A compact networking backup or small power station could maintain the router and recharge the laptop. Check whether your local internet service continues operating during a wider power cut. A powered router cannot restore a provider network that has also lost service. Mobile data may be your second connection, which means keeping the phone charged matters too. Level 2 is a standard desktop, one monitor and router. Here, interruption protection becomes more important. A suitable UPS can prevent the computer from shutting down immediately, while its required runtime depends on whether you only need a safe shutdown or several more hours of work. If you need extended operation, compare a larger UPS, a power station with verified switching performance, or a manufacturer-approved combined arrangement. Level 3 is a professional workstation with multiple monitors, powerful processors, dedicated graphics, and external storage. Measure this office during its most demanding real workload. A system that looks comfortable while the computer is idle may become overloaded during rendering, simulation, or other intensive work. Consider whether every monitor and peripheral must remain active. Backing up the computer's primary display, network, and critical storage may be more sensible than recreating the entire office on battery power. Level 4 is the critical home office. This is the person whose work cannot stop, whose equipment manages important business operations, or whose income depends on maintaining reliable communication throughout repeated outages. That office needs more than a battery. It needs a continuity plan. A continuity plan begins with immediate protection, enough stored energy, a realistic recharging method, and a second way to communicate if the primary internet connection fails. If outages regularly continue beyond the battery's runtime, you may need a larger installed system, a safe generator arrangement, or a hybrid setup. Buying more watt hours without a recharging plan only delays the moment when the battery becomes empty. Solar panels may help, but their real production changes with sunlight, shade, weather, panel position, temperature, and the charging limits of the power station. A panel rating isn't a promise of constant production. For a business-critical office, test the complete system before you depend on it. Run the computer under a realistic workload. Disconnect utility power in the controlled manner described by the equipment manufacturer. Confirm that the computer remains on, the router continues operating, and the system doesn't overload. Then measure how quickly the battery falls during real work. Check what happens when power returns. Confirm that charging resumes correctly and that the equipment behaves normally. A backup system you've never tested is still partly a theory. There are also several easy ways to waste capacity. Leaving unnecessary displays running reduces your working time. Connecting a laser printer can introduce a large temporary load that the system wasn't selected to support. Choosing capacity from the desktop power supply rating can lead to serious oversizing. Ignoring the rotor can leave you with a powered computer and no meeting. Assuming every power station switches like a dedicated UPS can cause an unexpected shutdown. And selecting a battery without considering recharging can solve the first outage day while leaving you unprepared for the second. So, how much backup power does your home office actually need? If you use a laptop and only need the router, phone, and occasional laptop charging, begin with a small measured load and choose enough energy for your normal outage duration. If you use a standard desktop and losing power instantly could damage your work, prioritize a suitable UPS or a power station with verified switching performance. Then size the battery for the number of working hours you need. If you operate a powerful workstation, measure it during demanding work, reduce unnecessary peripherals, and look for adequate continuous output, compatible waveform, and realistic capacity. If your office must operate through long or repeated outages, build a complete continuity plan, immediate protection, extended energy, recharging, and backup communication. The order matters. First, decide what must stay on. Second, measure its real working load. Third, determine how many hours you need. Fourth, identify which devices cannot tolerate interruption. And fifth, verify that the exact system you're considering supports the load, switching behavior, and operating arrangement you require. You don't need to recreate the entire electrical grid beside your desk. You need a system that protects the work that matters and gives you enough time to finish it. If you still don't know whether the rest of your home needs a portable power station, generator, installed battery, or hybrid system, watch our complete guide. Which backup power system does your home actually need? It will help you choose the system type before you begin comparing individual products. Your office doesn't need the largest battery in the store. It needs the right protection for the first second and enough energy for every hour that follows.